All right, I think we have our tube now ready to turn. I believe I'm really unsure as to whether it's gonna try to chatter on us. It's a good possibility that it will, especially in the center. We're not taking that big of a cut, but once you get chatter in something, it's really hard to get it out. So I think to start, I'm gonna go ahead and kind of find, somewhere down here that I'd like to stop my cut. I'd like to put the steady rest right behind it and go ahead and run that to help eliminate any of those chattery problems that we might have. We got our cardboard that we can put back on there, so it should keep it nice and clean. And then we'll go ahead and focus on this side, getting it turned to size. And then that'll finish this side right here. So I got me an area marked here that we can undercut it for the steady, and this will be a good indicator on what it's going to try to do as we turn it. Got our tailstock nice and tight with our live center in there. Not really feeling any. That doesn't mean it's not in there. It's actually looking pretty good. Now that is a coarse feed. That's 15 thousandths feed right there. But I think it's just gonna make me feel a lot better running the steady rest and not have to concern myself with chatter halfway through a cut and having to stop. So I think we'll just go ahead and get it set up. I'm gonna leave my tool on like a lead angle, so try to eliminate any possibility of chips packing in behind it and scratching the surface. Got to be really careful when you're setting those steady rests on something like this. Put too much pressure, you're actually pushing it, pushing it off center. All right, I'll get the cardboard sleeve up here, chip guard, and get that on, and then we'll be ready to turn. We'll make our first pass. It's only going to take 25 thou off of this, but what I want to do is just get a nice cut established there and see how it's going to react. We've only got 100 thousandths to take off this, so I'd like to get a finish on there. We'll kick it back to probably a 10 thou feed per rev to do our finish. Well, that didn't quite go as planned. Chip wanted to get hung up underneath that. Let me see if we'll find some pliers. Everything was working really well until that happened. But everything's looking good, sounding good. We'll go back and reset, make another cut. All right, so we've got about 65 thousandths to come off of this. I've got a slight amount of taper that I'm dealing with, so I'm working on adjusting the offset of the tailstock a couple thou at a time. So we're gonna take a 20 thou pass. My hopes is that we'll have approximately three passes to make on this to get it down to our size. Within 1,000ths, not bad. This is going to be my semi-finished pass here. I'm going to have another 10 to 12 thousandths. This has been a constant problem right here. Another reason why I haven't been setting the camera up for any long shots. I'm having to fight this. It keeps messing my finish up. As soon as I turn my back and I look down here, I come back and it's messing up my finish again. So it's just scratches. It's more annoying than it is anything, but not a big deal. So anyway, as I was saying, this is going to be my semi-finish pass. I keep getting about 0.02 taper, and I keep adjusting it. It would go the other way. I bring it back. So I'm trying to split that difference, and it's pretty difficult. Keep in mind, we've got, you know, an 80-year-old machine that's got quite a bit of wear on the ways there. It's not perfect. This is the kind of job you got to do right here in order to get this thing dialed in. And just because we may get it dialed in for this particular piece here doesn't mean that it's straight for the next job. You might have to bring the tail stuck up halfway and you got maybe a thou taper over there. It just changes on you, and that's just part of being a manual machinist running these old machines. You learn what you got to do to keep adjusting the tailstock to get it to turn the way you want to for the job. Unfortunately, I just didn't have a lot of material to take off this. This is why I've been taking, you know, 10-15 thousandths pass. So anyway, I'm getting it though. It's working out pretty good, and we'll be able to polish this with some emery to clean up the scratches on there. Getting down to our finished pass on this roller. 58. That's 57.5. 57.5. And 57. So it looks like I've got it down to 1/1000th taper from this to here, which is okay. My tolerance on this roller, I spoke with a customer. He's giving me 4/1000th tolerance. So the biggest thing is they don't want it oversized. They would rather it be on the smaller size of the tolerance, because they have some sleeves that are going to slide down this, a bunch of individual sleeves, they're calling it cartridges, that are going to slide on here and stack, and then the bearing nuts tighten them all up together. So they want to be able to take those things and slide them on there. So that's why they gave me the 4/1000 tolerance on it. I've got my finish turned right there. When I do a long journal like that, especially when I'm having to adjust it like this, I want to be sure I'm on my size. All right, finished pass. Chips just do not want to cooperate today. That's all they want to do right there. Scratch my surface. Sometimes a little bit of cutting oil will help that. I don't have my flood coolant set up to be able to properly dump it out over here on top. And I didn't feel like setting up my mister. I was trying to cut this dry, but I wanted to see if the cutting oil will help this out a little bit. Sometimes it does. I would generally only do that just on the finished pass, just to kind of just help the finish a little bit, and especially when those chips try to start rubbing the diameter. Well, there's the finished pass. I will say that the cutting oil definitely helped eliminate the scratching. I don't know if you can see down here. Got a few scratches. I started applying the oil here, and from there down, it didn't scratch anymore. I put a mic on it, see where I landed on my size. $147. 147. Looks like about 2 or 3 tenths. 3 tenths under 148. So I feel good. I feel good about that. We hit our size. I am within the tolerance that I was given on this. That looks good. All we got to do this is just kind of, we'll clean the oil off of it, and I will give this a buff with some Scotch-Brite. These scratches here, we'll probably hit with some emery. It looks good. I'm happy with it. All right, well, we got one half of it completed. Here's a better look at our finish. We got our stupid scratches right there, but you can see once I start applying the cutting oil from there down, we don't have any more scratches. We hit it with our Scotch-Brite. It's got a nice soft feel to it. Our finish looks nice and even. And I remiked it. We are good. We are good to go. So first thing we're gonna do is loosen the steady rest. I'm gonna slide it all the way down here as close as I can get. And I'm gonna get my tool in here as close as I can get to that. And I need to trim a true spot here for the steady rest. Once we machine that true spot, we'll set it to it, and then we'll loosen it up, take it out. We're gonna slide the steady rest down here to this end, and the tube will be set to run on the steady rest in that true spot. I'm gonna just clean it up. Well, that tool seems to be doing a good job. We might try that on the next end. I don't know how deep I went. I just touched it off until it cleaned it up. Maybe 10 thou. Yeah, that looks good. We might try that. That's an SNMG insert. I think what I'll do is I'll index it to a fresh corner. Since that did pretty good, I don't know, we might give it a try. That looks good. Okay, so I want to get this set. I locked this right here just for safety reasons, since you're right up against the chuck. A few chips got up in that roller there from that little bit of turning we just did. Let me see if I can blow them out of the way. All right, that's pretty good. Lock it to the bed. I'm going to slow this down, go to medium. what I'll have to do is open this up. But you can see what I'm doing though. When we flip this around, steady rest is already set to true. This is running true with everything that we just turned. So all this will be nice and true with our previous turned area. So for the chuck here, I'm going to run my copper pads, what I call soft jaws. Eighty thousandths out. Got it rolling on our steady rest. Less than 20. About 5. That's within about 1.5 right there. I need to close up the steady rest so it's not trying to whip around like that, and it'll help clear up a little bit of that. All right, there we are. All right, guys, so we're ready to start working on this end. So if y'all have watched the video up to this point, you've seen everything that we've got to do to this tube. We just got to do it again on this end. So we've got to face it, counterbore it for the bearing to press in there, turn and thread it for the bearing nut, and then once those are done, we'll move the steady rest down here to where we've already turned it, get it trued up there, and then turn this in. So I'm not going to go into a bunch of detail on this end. You know, I talked a lot about it on there, you know, trying to hit our sizes and feed rates and passes and all that kind of stuff. When I'm on a big job like this, it does take a lot of concentration on my end to get it done, and it takes a while to get it done too. So, you know, it's one of those jobs that's kind of getting to the point where I really want to focus on trying to get it completed and get it done. And since you already saw half of what we had to do, I don't really need to go into a bunch of more detail. But we're definitely going to give you some highlights of some of the more interesting stuff, you know, especially the single point threading and that kind of stuff. But I'm ready to get this job done and get it completed, so let's get started on it. So the first thing we're going to start with is the face. I have a dimension to get this faced off. There's a little tolerance there, so it's not super critical, but we want to try to get it as close as we can. So when I put this tube in there, I ran it all the way up inside there to the spindle face. All right, made sure it was pushed against it. So we have a 24-inch rule laying here, and now I've got my 60-inch rule laying up here on top of that, butted together. Everything's nice and square. And if we add the two up, it gives us 76 and 5/16 right there. Come up here with another rule and line that up. Sorry. Line it up like that. and that'll give me close. If you can read these lines on these scales, I've always said this, if you can read them lines, you can get a linear length like that measurement within 10 thousandths. So I'll take a careful measurement here on exactly where it's at and use this right here to get our length that we want of 76 1/4 according to the print. I ended up measuring 3/32 what I got to come off that face. We'll make a 16th cut on this, 2 passes at that. And it would help if I was feeding the right direction. Take a 30 thou pass, another 30 thou for it's about 16th, and then we'll measure it again with our rules, and we should be able to get that within 10 thousandths of our print dimension. I picked up that Starrett rule, this 60 inch at the Florida Flywheeler swap meet. One of my favorite tool vendors that was always out there. I haven't been in a couple years. I don't know if he's still going. He always had a lot of really cool machinist tools. And he had that sucker laying out on his table across all them tools, and I said, I gotta have it. And you see why you gotta have it. You don't use it all the time, but when you have it and you can use it, it's extremely helpful. So let's see what we got. Yep. So we have 1/32. I'm just going to dial in another 30 thousandths. That'll be 90 thousandths. That rule is lined up on that line, and it'll put us there. Make that face cut. I'll measure it and double check it though. $10, $20, $30. I'm gonna go ahead and set a 0 right here. Let's go ahead and check it again. I'd say that's lined up and we're within 10 thousandths of being to our linear length that we want. That looks good. We got the face, the outside journal done for the thread. Now I'm going to go ahead and finish the counterbore. Two-inch 340. We want 2-inch 440, so another 100 thou. I'm going to go ahead and slow the feed rate down by half. One thing I love about the pacemaker, if you have it in a 5 thou feed rate, you can easily go from 5 thousandths to 10 thousandths to 15 thousandths by just changing that one lever from A, B, or C. Those are like my three main go-to feed rates for the lathe work. 5 thou being a finishing, 10,000 being a sort of in between, and a 15 being a roughing. $390. Just gonna make a little cleanup pass so we can get a good measurement on this. $32 thousandths. I put these dial indicators over here on the cross slide. I think I mentioned this earlier in the video. It's just helpful looking at a dial indicator on your offset versus reading those little tiny lines on that old collar. I did that wrong. I already split it in half. I wanted to take 10. I was taking 5. Another 10 thousandths, and then that'll leave us our finish pass to make in here. I usually measure it at least 2 or 3 times when I want to go and take my finish pass. So this is telling me that I've got 11 thousandths to bring it where I want. So let's go for it. Dial in my 5.5 thou up here on the dial. Two-inch 440 thousandths. We hit that one right on the money. I always tell you I measured a couple times. Let's see if I get it repeated. That is right where it needs to be. $440. Man, that makes me feel good. Those bearing fits are always makes me the most nervous. All right, we need to swap this out, go in there and chamfer it. We're down to the last step of our machining job here, turning this OD. We are going to try this SNMG tool. It seemed to do pretty good when we made that undercut, right? I'm going to do some test cuts down here on the end, just a couple of light cuts, just to kind of see how it's going to react to our finishing pass. Because I didn't want to take the roughing pass and then get down to the finishing and then it kind of give me some problems. So since we got 100 thousandths to deal with here, I'm going to take a couple light passes just to see how it does. I've got it set at 10 thousandths feet per rev. That's what I finished the other side at there. And let's see what this will do. 10 thousandths. That's a 10 thousandths pass. I mean, that's looking beautiful right there. Let's try that one more time. Let's pretend that we're taking 10 thousandths for our finished pass. Well, I like it. I think we're going to go with that. Reset my feed, and then we'll go ahead and take a couple roughing passes to get it down close to size. That's looking good. Got a nice finish on there. Seems like the chip that's coming off of it is a little bit more manageable than what I was dealing with earlier. So we'll see if we can continue that trend. Want to give a good check on my size. Okay, good. That's going to give us just over 50 thou to finish it. I got to stop because somebody's banging on my door. All right. Joe stopped by. He's got a piece he needs me to help him machine. So sometimes you just got to stop and get the door. I keep my doors locked around here. I got my one roughing pass down. Now I'm working on my finished passes. I'll have about 3 of these to go. Testing my cutting oil theory to see how it's working on this tool right here. So far, so good. I got a little bit of smoke, but as I've always said, this is how you make your machine shop smell like a machine shop. Nothing wrong with that at all. I made a couple of changes. I went ahead and switched back to my previous tool that I was using my CNMG insert. And the reason why is because the finish that the square insert was giving me wasn't really consistent with what I previous machined on this side. That was, not that it's a huge deal, but I would like this to match the best that I can. So I've got a couple more passes to make on this to bring it down to size. The other thing I've done is add my Noga Cool, my little mini mister right there. And I've got some new misting fluid that I'm trying right there. You guys can see that. That's from Master Fluid Solutions, and it's their trim mist. I wanted to give that a try. I've always used Cool Mist in the past, and since I use their soluble oil in the machines, I wanted to try their misting solution as well. So we're giving it a try, and hopefully that'll help me kind of keep the chips cleared off of the tool and lubricated at the same time, and eliminate having to use the cutting oil there for the finish. So far it's doing pretty good. My only issue I ever have with the misting is that I can't ever get the amount of mist, the liquid coming out, to stay consistent. You'll get it adjusted and it'll be too heavy or it'll be too light where it's not getting anything. And that's just a common problem I've always had with misting tools right there. If I come up here and just touch that, see, I'm constantly having to adjust it. See, now we're getting some coolant out and it's too much. And if I bring it down, it's usually a little too little. It's like that tip gets clogged up in there. See how much coolant I got now? So this is why I have sort of a love-hate relationship with misting tools, is because of this right here, the inconsistency that I get. Anyway, I'm gonna keep working at it, get this thing finished up. Working on our final finish pass. Finally got the mister working pretty good. Our Kaiser air tower is keeping it topped off with plenty of air. I've been getting consistent readings on this side like we got over there. So I was getting, about 1 thou taper in there. But what we've been doing is, since I've got a 4,000 tolerance, I'm trying to land on the actual print size on the highest section and just letting the 1 thou be underneath that. And we should be there. I always start a little cut right there on the end, mic it just to be sure. When I've got a long cut, I want to be sure I'm on size before I take it all the way down the length of the part there. Just about finished up though. I'll bring you guys back and let you know how we finished out. All right, that was our finished cut. We're gonna put the mic on it and see what we did. We're looking for 3.148. $147.5. $147.5. Right in this area is where I've got just a slight rise in diameter. So right there, 148.5. $148.5. Come down here to the end, and it matched up really well. maybe a half a thou difference on the cut. And right there, 147 and a half right there. So we've got somewhere between a half and 1 thou right in this little region right here. And I'm gonna take some emery paper and hit that. It'll hit the tool marks and it'll bring, you know, a half down pretty easy. That's why I try to always hit, on something like this, I'm trying to hit my maximum diameter because we can always kind of take it down. But that's good. We've got a good consistent reading. Taper within 1/1000ths right in here, just like we did on the previous side. And let me show you that transition where we actually came into the cut right here. Maybe I should grab the other camera and show you. It came in and touched the previous cut on one side, and on the other side it didn't. I'm gonna say that's about a half a thousandths difference right there. So we'll be able to hit this with our emery and just kind of blend that together, but that's gonna be good. I'm real happy with it. The mist, that right there, the trim mist, I think worked pretty good. It's got like a, you know, it's got more of an oily consistency versus what I used in the past, which was the cool mist. It was more just like water, but this is actually a little bit more like the oil. So I think it does a little bit better job of lubricating the cut whenever you're using it there. So far I'm liking the trim mist. Real happy with it. I'm especially happy that I didn't get any scratches on that end like I got down here on this end. This is the kind of stuff that'll hurt your pride whenever this kind of stuff happens, and you got to try to do everything you can to eliminate that. So my fault for allowing this to happen on that end, but I'm sure the customers are going to be happy with it because they're going to take their sleeves and it's just going to cover all that up. Main thing is I've got it on dimension where they want it, well within the tolerance that they give me. All right, so we're all finished up right here. I want to go ahead and give it one last inspection with our beautiful Starrett micrometer and make sure everything's within tolerance. So let's go for it. .147. Our sizing, if you remember, is 3.148 plus 0 minus 0.04. So the highest reading that I'm getting is right in here, 3.147. Looking good. And then so here's our transition. This is where our cut stopped and met the other half. All right, 146. Let's check this side and see where we're at on that side right there. 146. So we have a beautiful match diameter right there. Maybe a half a thousandths difference because of the out of roundness that it was doing. So it's well within the tolerance that was given to me for this. It looks great. I'm really happy with it. So other than, we're gonna do a little polish right here just to blend this where the steady rest runs on it. I'm gonna loosen those up, polish that. And other than that, getting it out of the machine, this job is finished up. Job's done. Ship it. All right, guys. Well, this job is wrapped up. All we got left to do is load it up in the customer's truck and get it on out of here. So I enjoyed doing this job. I enjoyed sharing it with you. It was a great project for the American pacemaker, you know, using our steady rest and doing some threading over there. So I hope you guys enjoyed the video. I hope you enjoyed watching, and maybe it helped some of you guys out there too with your manual lathe work. And I hope to see you back here on the next project. All right, see you then.